Right, hello again. So we're going to move on to the new chapter, new unit, polynomial functions. We're going to talk about polynomials in this unit, section at a time, talking about their graphs, their characteristics, and everything that we need to know. Let's go with the definition first. So any polynomial of polynomial function um, which has a degree n. So we're going to explain what that means. It's like just like a polynomial expression that has a degree. It has to be written in this form. This is the form that is really crucial that has to be written. Notice that uh, there there are coefficients, and the coefficients are a sub n, but these are all just the notation so that you can see what is happening. Then it talks about the leading coefficients. An is the leading coefficients where n is the degree right here. That's the n, that's the degree of that polynomial. That's when we say degree n. And usually is written in a descending order in terms of the power of the x. So the next term after x to the n is x n minus 1, and so forth, so on. Then you have a polynomial function. Now, here are some examples of polynomial functions. First of all, the degree is the exponent of the greatest power of the variable. Okay, so remember that the degree of so n, which is the degree of the polynomial, is the greatest power of the variable x. Be non-zero only. It could be zero. For example, look at the constant function. This one right here, that's a constant function. So we could have f of x equals to 2. That's just basically a flat line, a horizontal line, and the y-intercept is 2. You could also have degree 1. So this is the degree 0. So degree in here, d, is 0. But here degree is 1. D is 1. Degree is 1. And notice that as we go through this, they could come up with a different format. Like I wrote this in different ways, but you have to realize, for example, this quadratic, if you expand it, it will look like a general form, right? So we could, this is just a vertex form, as you remember from last grade. So that's got a power of 2, so that x has a power of 2, so that is a polynomial. This and is a polynomial of degree 2. This is the polynomial of degree 3. Notice that in this one, it doesn't have the x squared, the quadratic term. That's okay. Nothing wrong with that. It has x cubed. That's okay. That's totally fine. So as long as it has x to the power of 3, nothing else really matters. So we can say that's a polynomial. And look at the x to the fourth. There's a negative in front. That doesn't matter. It still follows. So that's the degree 4. We call it degree 4. There's a name for that. By the way, degree 3 also is called cubic function. And fourth is called the quartic function, and then it can go up degree 5, degree 6, but I just wanted to put another kind of a funky one to the power of 49, right? So this polynomial of degree 49 can also, you could also have that as not a problem at all. All right, and then I want to show a few. So this is the degree 49, okay? The example of non-polynomial functions. So as long as you have x that is not written in this form, which is the general form on top, okay, x to the n, and x is either in a denominator under the radical sign or exponents, none of these are. And I can go on with many other examples, but you get the point. All right, they have to have the same form which is written up here. All right, so none of these are, therefore they are not polynomial functions. All right, every polynomial function has specific characteristics. All right, but in general they all share few things, some fundamentals. So there are 4 or 5 things that they share. So first of all, every polynomial function will have some kind of a degree. We know that we have to know the degree of the polynomial, and it does matter if it's a degree, odd degree, or even degree. And we're going to talk about that because that changes the behavior of the graph of that polynomial function. The next one is the end behavior, and end behavior is actually related to the degree. These two are related, obviously. All right. So the end behavior, basically number of turns, number of curvatures, peaks and valleys, stuff like that. That happens with the polynomial functions. The next piece, domain and range. Now that's not specifically for functions. Any relation could have a domain and range, but for the polynomial functions, we also need to know. But usually with these ones, we're gonna rely on the graphs as much as we can, so we can have a sense of what type of a graph it is, the shape of a graph, and then we can come up with the domain and range. And then the very important part of the polynomial functions has got to do with the number of x-intercepts. How many times the graph of a polynomial function passes through or goes through the x-axis, okay, crosses the x-axis. And those values are very, very important because they represent certain information, so that we can actually use that to analyze the behavior of the function. All right, and then we're going to talk about that, and that also is related, very closely related to the degree of the polynomial. They're all related, okay? Those 3 are really related to each other. All right, now look at some of these examples. I started with the flat one. This is another one that I chose from the textbook, but simply we start with the degree 0. That's a constant term, which is right here. Okay, so we have a flat line, f of x equal to 3. Then we have a line, which you're used to, y equal to mx plus b. And notice that the end behavior. So what does that mean? It means that basically what is happening, where is this graph is located? In this graph is located in quadrant 1 and quadrant, so this is Q1 and Q2. Quadrant 1 and 2. Okay, that's what we call end behavior. How is it related? It's flat. This one is a slanted, but is in quadrant 1 and quadrant 2. Okay, you got the quadratic. The end behavior on this one, it goes basically in all quadrants, but basically it starts, or basically both of them starts and extends in both quadrants, quadrant 1 and quadrant 2. But then within all of these, you notice that there's x-intercept, y-intercept, we can have domain and range. Everything is written in here, and these are the information that we need basically for every polynomial functions. Okay, so first the end behavior, then we're gonna go ahead and talk about every other information that we talked about, those 4 or 5, domain, range, and number of x-intercepts and y-intercepts. Next one, the cubic, degree 3, right here. This degree 3, the general shape of a degree 3 cubic, it looks like that. It looks like a little kind of a curvature. It has a kind of a quadratic part to it, okay? If you look at this part right here, the second term, that's a quadratic term of the cubic function, but it looks like that it's in between quadrant 1 and quadrant 3. That's where the general shape of the cubic function with the positive leading coefficient, okay, with the positive leading coefficient that happens. Then there are, and then notice that the domain and range are both of them are basically real number sets. And then how many intercepts do you see? Well, in this case you see 1 in here, 1 in there, 1 in there, so there are 3 of them. Okay, degree 3, this could have 3 intercepts, but does it have to always go through 3 places on the x-axis? We don't know. We're gonna explore that more. All right. Then look at the quartic function. The quartic function, same idea. The general shape of it looks like a W in a different form depending on the other terms, cubic, quadratic, and linear term. And then obviously it has set of, again, characteristics that we have to follow, quadrant 1 and quadrant 2. And notice that the quadratic and and quadratic and quartic degree 4, they're the same in terms of the end behavior. You see that? And then notice that the cubic and then the power of 5, or we call it quintic, they are also the same. You see, quadrant 1 and quadrant 3, that's the end behavior. But obviously the number of x-intercept changes. This one is going to have 4, this has 5, but these are the maximum numbers that you can see, and we're going to explore that way more in next sections. All right.